Alright, so we're going to start talking about translations of a graph. So remember when we identified the amplitude, midline, maximum, minimum, starting point of the sine and cosine functions? So let's take a look at what the a value was. We said that the a value in this function represented the amplitude. What we will actually call that now is a vertical stretch. So amplitude is the same thing as a vertical stretch. Amplitude is just a fancy word for when we're talking about sine and cosine functions. Same thing happens with the c value. We used to call that a phase shift with sine and cosine. We're now going to call that a horizontal shift. So moving from left to right. And our d value was our vertical shift. We're only going to call it midline when it's sine or cosine. So now we're going to generalize all of these things, a vertical stretch, a horizontal shift, and a vertical shift, to some more general functions. So let's take a look at what it looked like with our sine function. Okay, we're going to start talking more about parent functions, which is the original function without any changes. So when we graph the parent function of sine, it goes from 0 to 2 pi. Okay, so we go from 0 to 2 pi with our original sine function, and our original midline is at 0 with our max and min at 1 and negative 1. Sine starts at the midline, goes up to its maximum, back to midline, to minimum, and back to midline for its parent function. So that is one period of the sine graph without any changes. When we look at this changed graph, the negative 3 sine of x minus pi over 2 plus 2, let's go ahead and identify our a, c, and d. A is a negative 3. C is a positive pi over 2. And D is a positive 2. So our midline is now going to change to 2. So we've got a vertical shift of 2. Okay, so our midline is also a vertical shift. We've got a vertical stretch, or our amplitude, of 3. Remember that amplitude is absolute value. So our maximum is at 3, and our minimum would be at negative 1. So now our starting value is at positive pi over 2. So now sine will be starting at 2 over pi over 2. And then we will move up to its midline, after its maximum, back to midline, to its minimum, and back to midline at 5 pi over 2. Causing our curve to be stretched and shifted to the right, as well as being shifted up. So we have a vertical shift from our D value, a horizontal shift from our C value, and a vertical stretch from our A value. So what if we gave you a generic function that looked like this? Y equals A times the function of x minus h plus k. What letters match up when we're doing y equals A times the sine of x plus c plus d? A and A match. Sine is our function. C and H both represent our horizontal shifts, and D and K both represent our vertical shifts. Transformations and end behaviors. There are two types of transformations. We have translations that are represented by H and K, and we have reflections that are represented by positive or negative A. So just like our sine and cosine functions, if we have a negative A value, our graph is going to be reflected. So please have this written down as your notes. Y equals A times the function of h minus x plus k. It's important to remember that inside the parentheses, we have opposite, and outside of the parentheses, we're going to have the same. So if we have x minus h, it's actually going to be moving in the positive direction, to the right. And if we have x plus h, it's going to be moving in the negative direction, to the left. Versus k, which when k is positive, it's going to move up, and when k is negative, it's going to move down. And again, h is our horizontal, and k are our vertical translations. Reflections deal with the A value. Whenever A is greater than 0, or less than 0, my fault, or it's negative, it's a reflection about the x-axis. Whenever A is positive, there's no reflection, so it will be going in the same direction as the original or the parent function. So let's actually try one of these. Our parent function that was given to us is x squared. Let's go ahead and take a look at what an x squared function typically looks like. We have the vertex at the origin, so at 0, 0, and it kind of looks like a U, going up in both directions. Now we're going to describe the transformation of g of x if g of x is equal to the function, or f of x minus 3 plus 4. Our a value is always out front. So we have, so a is the same, or it's a 1 in this case. Our h value is always opposite of what we see in the function. So our h value will be a positive 3. And our k value stays the same. So our k value will be a positive 4. Meaning that we're going to move up 4. So if we look at our critical point, we're going to be moving that point right 3 and up 4. We're going to plot our new point there, and we're going to have the same basic shape. There was no reflection, so it should still be opening the same way as it did in the parent function. That's all of our notes for today. Please make sure to ask any questions during class that you need.